Hello everyone. A very warm good morning from here, Toronto. So today, in this tutorial, we're going to learn about software testing by team APA. APA is just an acronym for us four people: Antriksh, Abhishek, Parimal, and Aditya. So without further ado, let's start with the tutorial. So the contents of the course will be a basic introduction to the world of software and software testing, some famous test studies that demonstrate the importance of software testing, quality assurance and quality control, types of testing, testing methods and their various levels, software testing lifecycle (STLC), agile extreme programming and scrum methodologies, and finally traceability metrics and its use. Also, there will be a bonus content in this tutorial series, which will be me with the help of Eclipse IDE setting up a few basic test cases in Java programming language. So basically, what's a software? So a software is simply put any piece of data or instruction that is given to any device, could be a phone or a laptop, and which tells it what to do. So there are many software all around us, like Microsoft Office, MS Paint, or any game or application in your phone. Even the video that you're watching this in is a type of software. So what is software testing? So while creating and developing these kind of softwares, the developer faces many kinds of bugs, or sometimes the end result is not as what the client or the user need. So for that, we keep on testing the software continuously, so that to make sure it is defect free. So what's the importance of software testing? Why do it? So first of all, it saves us time and money. For example, you're developing an application for a month, and every day before signing off from the office, you're always making sure that it runs all the test cases and then none of it is broken. So it saves a lot of time, and time is money after all. So by saving time, it also reduces the labor cost and improves the condition of the budget. Second is providing security. Of course, when we know that our software is bug free, it automatically increases the security level of the application. And similarly for the quality, the fewer bugs, the better the quality, and in turn the better customer satisfaction. So here's the first case study. Last decade, in 1999, a Mars or climate orbiter was launched by NASA into space. So it was a total cost of 125 million, which according to adjusting by the inflation today could be around 500 million. So the thing was that when it entered the Mars orbit, it two teams have developed the software together, and one of them was using meter per second square to calculate its acceleration, and the other team was using pound per second square. They had a miscommunication, and of course, when the value for which it had calculated, by which it had to decelerate, was changed from meter per second square to pounds per second square, it immediately fell into orbit and crashed. So it was a pretty big waste of a lot of resources and a lot of human hours that had been put into this project. A similar case happened due to lack of testing in Europe's new satellite launching rocket system, which was the Airline 4. So the new software was trying to cram a 64-bit number into a 16-bit number. So of course it could not fit in, and that resulted in the plane misbehaving, and it eventually crashed. That was a $8 billion project. Alright. Now that we have seen the introduction of what is software and what is a software testing and why is it important, I'll let my friend Parimal, who has done extensive research on testing, let you know what is testing and what it is not.
Thank you for your introduction, Antarik. So let's move on. What is exactly testing? So testing is a process of evaluating a system with the intent or the purpose to find whether the specific requirements are met. In other words, testing is executed on a system to identify any bugs or missing requirements which are provided by the customer. So who all are involved in professional testing or software testing? So software tester, software developer, project manager, and finally the end user are the ones who are involved in software testing. So what is quality assurance, quality control, and testing? So quality assurance includes activities that ensure the implementation process and procedures and standards in the context of verification of developed software and the intended requirement. Quality control includes activities that ensure the verification of the developed software with the respect to the documented requirements. And testing, it includes activities that ensure the identification of bugs, defects in a software. What does quality assurance focus on? Quality assurance focuses on processes and procedures rather than conducting actual testing on a system. What does quality control focus on? So quality control focuses on actual testing by executing the software with the aim or the purpose to find a bug or defect through implementation of procedures and processes. And testing basically focuses on testing. So quality assurance, what activity is it oriented to? Quality assurance is a process oriented activity. Quality control is product oriented activity, and testing is also a product oriented activity. So what process is quality assurance? Quality assurance is a preventive process. Quality control is a corrective process, and testing is a preventive process. Whose subset is it? Quality assurance is a subset of software testing lifecycle. Quality control is a subset of quality assurance, and testing is a subset of quality control. What is testing and debugging? Testing involves identifying a bug, error, or defect in a software without correcting it. Normally, professionals with a background of quality assurance are involved in bug identification, and testing is performed in the testing phase. Now, what is debugging? Debugging involves identifying, isolating, and fixing the bugs while in the development mode. And developers who code the software are, are responsible for debugging, like while they encounter an error in the code, they fix it in the debugging mode. And debugging is a part of white box or unit testing. So what are the types of testing? Manual testing and automation testing. So let's move on with manual testing. Manual testing includes testing a software manually, that is without any scripts or softwares. There are different stages of manual testing such as integration testing, unit testing, system testing, and user acceptance testing. Manual testing also includes exploratory testings as tester explore the software to identify errors on it. And automation testing is when the tester writes scripts or uses a software to test the product. This process involves automation of manual process. Automation testing is used again and again to rerun the test scenarios that were performed manually, quickly, and repeatedly. So when to use them? When to use manual testing? So first of all, manual testing is useful when we need flexibility as testers, when the projects are of short period or short term projects, when usability is being tested. And when do we use automation testing? When working on large and critical projects, stable software with respect to manual testing, and when the requirements of the customers are not changing frequently. Okay. Now my friend Abhishek, who has done extensive research on software testing, will teach you about different types and levels of testing methods. Thank you.
Hi, this is Abhishek Kapoor. First, I would like to thank Parimal for letting us know about the manual testing and automation testing. And so, moving on further, I would like to talk about the different testing techniques that we use. So, the first one is black box testing. In this technique, we don't need any knowledge about the interior workings of the application because we are not dealing with the source code, and we don't need to know about the architecture of the software. So this is basically black box testing. The main advantage of using black box testing is that large number of skilled testers can test the application without knowing proper implementation or programming language, and it is not and the testing does not depend on any operating system. The other advantage is that the code access for the current software is also not required. The disadvantage is that it is basically an insufficient technique to use for testing because the tester has very limited knowledge about the application as the tester is not going through the source code. So the other method to do testing is the white box testing. It is simply the opposite of black box testing technique. In this technique, we do the detailed investigation of the internal logic and structure of the code. And this white box testing technique is also known as glass testing or open box testing. So to perform this testing technique, the tester must know the inner working of the applications. So let's talk about the advantages and different disadvantages of this technique. The main advantage is that it is it helps the code to optimize. Like it is very easier to optimize the code as compared to the black box testing technique. Also, the length of the code can also be shortened, uh, and extra lines of the code also can be removed. As in this technique, the tester must know the internal workings of the software, so maximum coverage is attained during the test scenario writing. And let's move on to the disadvantages. Uh, as it says, sometimes it is impossible to look into every corner to find each and every error in the software. So it is a very long task which is very difficult to implement. As in this technique, some skilled coders and testers are required, so the cost efficiency gets very lower as the cost for hiring a skilled tester has been increased, and it is very difficult to maintain also. So let's talk about the different levels that we use for testing. So first one is functional testing. It is a type of black box testing technique that is based on the specifications of the software that is to be used. Like this technique is used for the specific type of softwares, and the functional testing is simply the opposite of that. In this type of technique, software testing, uh, we usually rely on the aspects of the software that are related to performance, usability, and reliability. Uh, so now we are going to talk about the functional types of techniques or testing techniques. So first one is unit testing. As it says, it is performed by the tester before the setup is handed over to the testing team to formally execute the test cases. Integration testing. As the name suggests, we simply integrate the software into different parts, and in this technique the testing of the combined parts of an application is done to determine if they function correctly. System testing, as simply the name is suggesting that we are testing the tests are being run on the system as a whole. And the last one is regression testing. It is performed to verify that a fixed bug hasn't resulted in another functionality or business rule violation. So basically in this technique we check that there is not any violation being made while removing the bug or making some changes. The other one is acceptance testing. In this technique, more ideas is shared about the application and more tests are being run on the application to increase the accuracy. Next one is alpha testing. So this is the first stage of the testing and is performed among the whole team, which includes developer and QA teams. Beta testing. It is rightly done after the proper testing through alpha testing. So let's talk about some non-functional types of techniques. So the first one is testing. It is mostly used to identify any bottlenecks or performance issue rather than finding bugs in a software. So in this testing, we simply try to find out the how the system is performing on this software. The next one is load testing. It is a process of testing the behavior of a software by applying maximum load in terms of software assessing and manipulating large input data. The next one is stress testing. Uh, it is sim- it is simply being done like when you put too much stress on the software to check to check the endurance of the software, and we put the software into abnormal conditions to check for that. And the last one is usability testing. It is a black box technique and it is used to identify any errors and improvements in the software by observing the users through their usage and operation. So that's it.
Hi, thank you for the generous introduction, Abhishek. So my name is Aditya, and I am going to walk you through with some of the test methodologies. So let's start off with a test plan. So what is actually a test plan? A test plan, as you can see, is a detailed documentation describing the test strategies, objectives, deliveries, and resources required to perform testing of the software product. Okay, take an example. If the software product is a building, then its test plan would be the blueprint of the building. And such kind of test plans are usually prepared by the test lead of the group. And what are the things that a test plan focus on? The first thing would be that what are the things that should be tested? What are the things that cannot be tested? What should be the tools used for testing? What are the risks and what is the testing duration? So now we know that what a test plan actually is, but do we know how to make one? So it's pretty easy as per theory, but it has a lot of steps inside it. First of all, we need to know about the product. So the analyzation of the product is a must. We need to design the test strategy and its objectives. We need to plan the resources that are going to be used for the tests, plan the environment of the test, and schedule the time duration for the test. And last but not the least, determining the test deliveries. So now we come to a test scenario. So what is a test scenario? Test scenario is basically a functionality, any functionality that can be tested. So basically it's a quick tool to determine the testing work effort. It also ensures that the test coverage is taken properly care of and the software is working for most of the cases. So what is a test scenario used for? It is basically used to determine the end-to-end transactions of the software applications. Now let's move to a test case. What is a test case? A test case is basically a set of actions that is required to verify a particular feature of your software application. And it is basically used to determine the functionality of the software required by the customer. Okay, let's take an example of an e-commerce website like Amazon. So what should be the test cases? The first thing when the login page shows up is when you enter a valid user ID and password. So what should be the results? That is one of the test case. The second test case would be what happens if you enter an invalid user ID and password. And the third one would be what if you leave the positions empty? Well, you don't write anything. How should the website behave? So these are the test cases. So how to write a good test case? Certain things that you should keep in mind are to make it simple as possible. Keep the end user in mind because it's the end user that is going to use it after all. Avoid repetition of the same thing because that can make the code and the test big in size, lengthy. Do not try to assume anything. Anything that you assume is kind of a bug in the test. Ensure that it's 100% secured. Use as many of testing techniques as you can. And always set it for review. That is the most important part of a good test case. So, what is a software testing life cycle? A software testing life cycle is basically a sequence of activities conducted during the testing process to ensure that all the software quality goals are being taken care of. It involves verification and validation both. So there are a series of steps in this life cycle, and each and every step has an entry and exit criteria. So what is an entry criteria again? Basically, an entry criteria are a set of items that must be taken care of before the testing can begin. And as the name suggests, exit criteria are the prerequisite items that should be taken care of before the testing is concluded. So there are actually 6 phases in the software testing life cycle. The first one is the requirement analysis stage. In this particular stage, the requirements are evaluated to identify the aspects. It may also need the stakeholders to clarify the requirement. Once it is clarified, it moves to the test plan. Basically, this part of the life cycle includes making a test strategy in a test plan document. Then we move on to the test design. In this particular case, the test cases are created, and these cases include input, proceedings, and the results of the testing. Then the environment setup. So we all know that in order to proceed with a test, there should be an environment. So in this particular stage, the testing environment are configured, and it might use Selenium or a PM, for instance. When all these 4 stages are being taken care of, then it comes to the test execution. So test execution is actually the tested, it features the tested and deployed environment and using the test cases made in the test design. And at last is the test closure. Test closure is basically the report prepared. It might be called as a summary of the actual test, and it takes care of all of everything, suppose like the time taken, the cost, and the coverage. So now we are going to move on Agile. So a brief summary to Agile would be, it is the ability to create and respond to the change. Basically, it is the way of ultimately succeeding in an uncertain environment. It serves as an umbrella for a set of frameworks and practices based on principles. A big focus in the Agile software development is on the self-organizing team. It states that business people and developers should work together daily throughout the project. And it follows 12 principles for executing in the agility, which we will not go into at the moment. So, moving on to extreme programming. Extreme programming is one of the agile software development framework. It aims to produce high quality software and high quality life for the software development team as well. The 5 values, which are very important, are communication, simplicity, feedback, courage, and respect, usually practiced during the dynamically changing software requirements. So, when should one practice extreme programming? So, this is basically a diagram of all the loops and the processes involved in it. And how do they work? So, under the process of extreme programming, the feedback and the plan updates occur really quickly in each of the phase. The iteration of that release happens in weeks, acceptance testing happens in days, and the unit testing happens in minutes. So the frequent small release and short iteration enable the code to be thoroughly tested. Unit testing also ensures that the defects in code are detected, and the customer acceptance testing ensures that the system actually meets the customer's real needs, because they are the end user. The only downside to extreme programming is that it requires extensive customer involvement in the development process, which may not be possible in all situations. So, let's move on to Scrum. A brief summary on Scrum would be, it is basically a framework within which people can address to complex adaptive problems while maintaining the productivity and creativity of delivering products to the highest possible value. It is basically a simple framework for team collaboration on complex products. Why Scrum used? Because it's lightweight, it's simple to understand yet difficult to master. Scrum has a framework in it, and the basic 3 artifacts to it are the product backlog, the sprint backlog, and the backlog tasks. These artifacts provide minimum set of material to plan, execute, and review the sprint in it. The practitioner understands to implement these artifacts in complex real-world situations. So what is a product backlog? A product backlog is basically the product features desired by customers and the priorities by the product owner. It moves to the sprint backlog then. A sprint backlog provides the product features committed for the current sprint and features committed by the Scrum team as well. So then it moves to the backlog task, which moves to a 2 to 4 weeks of sprint time walks. The sprint planning meeting makes sure that the review of the product backlog is taken care of. It commits its work for the sprint, and it makes a task estimation. It has daily Scrum meetings in which certain questions are discussed, like are there any impediments, or what is the team planning to accomplish before the next meeting. After that, we move on to the sprint retrospective meeting, in which certain questions are asked and answered. So the question asked is what went well during the last sprint, or what could be an improvement in the next sprint. And at last, it's the sprint review meeting, in which the demo of the work is given, the review of the total project is taken care of, and the work team commit to their target of delivering the project on time. So, moving on to traceability matrix. What is it? Basically, it correlates two baseline documents that require a many-to-many relationship to check the completeness of the relationship. It's basically an Excel sheet that you have to prepare, and I will be giving a demonstration to that with an example in the next slide. So, holding back to the basics, it is used to track the requirements and to check the current project requirements are met or not. So the requirement traceability matrix is basically a document mapping and tracing the user requirements using test cases. What is the main purpose of this RTM? It is basically to validate that all the requirements are checked and there is no functionality that is unchecked during software testing. Basically, there should be no functions which has there should be no methods or class which has no functionality in the program, because that would be extra code, that would be a bug. So basically what it does is that it confirms 100% of the test coverage and helps in analyzing the impact on the QA team, basically the quality assurance team's work, with respect to revisiting or reworking on the test cases. Now, moving on to an example. As you can see, the left side of the table has a functionality, and the top part has a class name, a row containing the class name and a row containing the method name. So basically what a traceability matrix does is every class name has certain methods to it, which serves certain functionality. So traceability matrix takes care of the functionality and matches it with the class name and its methods. And by this, we as programmer testers, we while testing a program, make sure that all the functionality of the methods are totally up to the mark and there is no method or class which is of no use in the program. So let's just get explained with this. So a class name of user authentication.java has two methods in it, called the check username and password and validate the username. As we can understand by the method name itself, this is basically used to check the username, basically used to check the password and the username. So basically the functionality to access user's username and password moves to this portion and we say a yes to it. Stating a yes makes sure that the method name has the right functionality and it's working in the program. The same case goes to the second class name, which the class is account details and its method name is to fetch the user's balance. And the functionality that it serves is to access the user's balance, hence a yes to this end as well. Now check on this, that the access user's balance does not have a yes portion with these two methods because it doesn't serve that. And by this, we know that this particular functionality is used by this method or this class. So this is how a traceability matrix work in real life. So we have really come a long way through the software testing procedures. And most of this would be theory, but trust me, it's not the end yet. And to move forward, I would like to invite Antariksh to take care from now with the JUnit testing and codes. So interesting things coming up next.
Alright, thank you Aditya. So now we are going to quit the PowerPoint presentation and start off with the Eclipse project so that we can create a JUnit test case in Java. So I'm going to use Eclipse Spring tool suite, but you can use any other tool suite that you want. So I'm going to create a new folder, JUnit testing. Select folder and I'm going to launch the workspace. Alright, so a new workspace has been launched. So what I'm going to do here is I'm going to create a new project and I'm going to go for a Maven project. Click on next and I'm going to select Maven. Oh, that's a typo right there. I'm gonna select the Maven archetype quick start because that's gonna give me a pretty good POM XML to start off with the project. Where is it? Where is it? Here it is. Quick start. Alright then. Next, group ID is gonna be com.demo testing. Yeah, as good as any. Alright. So my basic project setup is done. So what I'm gonna do is go to the build path and add JUnit 5. Libraries, add a library, JUnit 5, yeah, that looks good. Apply and close. So what I'm gonna do quickly is gonna go Maven and update the project with all the latest dependencies. Okay, so it gave a JRE error. I'm gonna quickly set up my JRE. Build path, configure build path. Add adjors, a library. JRE 1.8. Oh, I already have it. Apply and close. Okay, that should be good. So what I'm gonna do is create a class and call it my unit, which will have my unit case. So this will have a method that accepts an array as an input and returns the maximum integer of the array as a result. So I'm gonna quickly code that. Alright, so it's gonna set an initial variable as 0, and whenever it finds a greater integer than the original 0 is gonna get replaced. It's gonna iterate through the array and the maximum result is gonna be returned. So I'm also gonna create a unit test case. In which I'm gonna use the annotation test. I'm gonna create an object of my unit. I'm just gonna check for the code in which I'm gonna give a expected value of 10 and a new array of integers which has 4, 7 and 10. Oops, missed the syntax. Yeah, that's good. Forgot to call the method. Find max. It's gonna take the array as an input. New int and 10. So what I'm expecting is that it should find the maximum value in this array, and the expected output should be 10. So I'm gonna run this as a Java test case. I'm gonna delete the app.java file because I don't need that. Alright, I'm gonna clean bin the project. Okay, looks all good. So it's gonna run whatever is in com.demo testing. With JUnit 5. So it ran the test case and it was the correct result. So what happens when I tweak the result? Like I tweaked the array and now it has an element of 11, but it says that our result should be 10, which is clearly false. In that case, the result will it will raise an error. Let's just check that out by rerunning the test case. Yeah, right there. So it gave an error. And it clearly says in the description, where did it go, that expected was 10, but the actual result was 11. So what happens when I do some edge testing? Like I give the input of -1, -4 and -20. So out of these value, we know that the correct answer is -1 because it is the maximum of the integer, maximum value of an integer, and we're gonna give the expected output also as -1. So let's run this test case. Rerun, and it gave an error. This is because it was expecting -1 but was given 0. So what is the flaw here? Why did it give 0? It should clearly give -1. 0 is not even an entry in this case. So there must be a flaw within our coding. So the flaw is that we already set the maximum as 0. So that's why the value will never be decreased to 0. What it should actually be is integer dot minval, which is something like -2,147,000,000 something, the lowest an integer can be. So it was because of testing that we were able to find our flaw and were able to fix it, because we asserted that whatever we give as a expected output should actually be the output of the condition. So let's rerun the case again, and this time it's called correct. -1 is the correct answer because it is the largest value of these three. So this is how this is one of the small example why testing is so important, and why we should always start testing from the moment we start to develop our application and write code. So thank you for attending this lecture. I hope you learned a lot, and we'll see you next time.